Okay, so let's continue by simplifying square roots with coefficients using properties of multiplication. You're still going to need to find the largest perfect square factor of each radicand. And you can use the list on the last page, but you should have the first 20 memorized. If it helps you out to list, you can list the first several, as many as you need, so that you have them. It might be easier to access them if they're listed at the top of the paper. Okay, so the only difference in example 2a is that now we have a coefficient in front of the radicand. We know the term coefficient when we were working with variables. It was the number that was attached to the variable. So now the coefficient is the number that is attached to the outside of the radical. So it still has to stay outside of the radical, and we're going to simplify the radical just as we did in the previous examples. So the square root of 32. If I go up and try to find the largest perfect square factor, I know that 16 is a factor of 32. 16 times 2 equals 32. And I keep the coefficient of 2 on the outside. Now, I can simplify. The square root of 16 is 4. Bring down the 2. Radical 2, that's not a perfect square, so I just have to leave it as radical 2. 2 times 4 is 8. So the simplified radical would be 8 radical 2. Example 2b. What is the coefficient? The coefficient is 1/5. So the 1/5 stays on the outside, and I'm going to simplify the radical. I need to think of perfect square factors of 150. So I see 25. How many 25s are in 150? 25 times 6 is 150. So now I can simplify. Bring down the 1/5. The square root of 25 is 5. Radical 6, does that have any perfect square factors? No. So that's in simplified form. How do I simplify 1/5 times 5? I'm just multiplying the two numbers. So 1/5 times 5 over 1 is just 1 radical 6. So in simplified form, that would just be radical 6. Okay, you can shut off the video now and try a few examples, and then check your answers on the board with your group. Okay, the final examples will be multiplying and simplifying together. So now we have two separate radicals being multiplied together. So the square root of 13 and the square root of 8. Neither one is a perfect square, so I can't simplify them as they are. So let me multiply 13 times 8, and I get 104. So the square root of 104. So now I need to think, what are the perfect square factors of 104? Well, 4 goes into 104 26 times. 4 is my perfect square. 26, does that have any perfect square factors? Again, let me list the first few so we can take a look. We don't need to go too high because 26 isn't that large. 4 is not a factor, 9 is not a factor, 16. No, so that is in simplified form. So the square root of 4 is 2, and the square root of 26 cannot be simplified any further. 3b, the square root of 3 squared. So what does that mean? When I square a number, I multiply it by itself. So what number's in the parenthesis? The square root of 3. The square root of 3 times the square root of 3. We learned today when the two numbers are under the radical, we can multiply them together and leave it under the radical. is the square root of 9, and the square root of 9 is a perfect square, which equals 3. But there's a nice easy shortcut that we learned when we first talked about radicals this year. The square root of 3 squared is just 3, because the square and the square root cancel each other out. So all I'm left with is what's underneath the radical symbol. It's a nice shortcut when you're squaring a square root. Example 3C. Now notice you have a coefficient attached to this radical and a coefficient attached to this radical. So you have to be careful here. The coefficients are able to be multiplied together, and the radicals are able to be multiplied together. So I can multiply the two coefficients, 3 times 4, and the two radicals, radical 3 and radical 6. When I simplify 3 times 4, I get 12, and radical 3 times radical 6 is radical 18. Now I have to think, radical 18, can that be simplified? Does it have any perfect square factors? Sure it does. 9 is a factor of 18, and that's a perfect square. So 9 times 2 would give me radical 18. I know that the square root of 9 is 3, and radical 2 is not a perfect square, so I have to leave it as radical 2. It cannot be simplified any further. Now I can just multiply the coefficients, 12 times 3, 36, and just bring down my radical 2. The final example. Again, I have a coefficient attached to the radical, and then another coefficient attached to the radical. So I can multiply the coefficients together, and I can multiply the radicals together. So negative 5 times 4, and then I'm going to multiply radical 3 times radical 15. So negative 5 times 4 is negative 20. Radical 3 times radical 15 is radical 45. Now we need to simplify radical 45, if possible. Does 45 have any perfect square factors? Think about your list of perfect squares. 1, 4, 9. Yes, 9 is a factor of 45. 9 times 5 equals 45. So I bring down my coefficient of negative 20. The square root of 9 is 3. Radical 5 cannot be simplified any further. Again, I need to multiply my coefficients and bring down the radical. Negative 60 times radical 5.